Okay, good evening, ladies and gentlemen, and welcome to day two of Lean Six Sigma Green Belt Hackathon. All right, a lot of people are yet to join, but let's start the journey with our revision of yesterday's topics. Okay, yesterday we spoke about 86-14 rule, and let me prove that 86-14 rule right away in this revision. All right, chalo. So, fatafat, whatever we have covered yesterday, can you just type in the chat box? Can I have the screen a little closer, please, for me? Thank you very much. Yes, superb. Type in the chat box whatever we have covered yesterday. It can be random. You don't have to follow the sequence. Okay. I hope you guys have taken the notes. Okay. So today we will directly go to the Minitab. Directly meaning, of course, I'll just cover a few topics today, and then we'll go to the Minitab. So, chalo, type karo fatafat whatever we have covered. All right. So strategic forces we have covered. Mean, mode, median. Okay, 86-14. Yeah, it's 86-14. Not 84-60. Yeah, 86-40. So 86% that now we are recovering that amount with whatever we have lost. So this is a recovery phase of 86%. So how do we recover? By revision. Okay. Then what else? Mean, mode, median, strategic forces. बीच में कुछ नहीं लिया था क्या? Okay, project selection. Very good. So there are various strategies of project selection. Who does project selection? Master Black Belt does it. Okay, Cano model. We have seen Racimetric, SIPOC, vocabulary of Lean Six Sigma, VOC, VOD, VOP, and all those things, right? Father of Six Sigma is who? Bill Smith, right? Percentile, not projectile, percentile. Yeah. So driving forces, projection, project selection sources, yes. Mean, mode, median, standard deviation, SIPOC, very good, very good. Super, super. Percentile and quartile, super. Only you remember the topics, or the meaning of the topic also, I believe you remember, right? What is mean, what is mode, what is median, correct? What is percentile, what is quartile? Today we are going to see what is the applicability of that. Unimodal, bimodal, uniform distribution, very nice, super. Stakeholder analysis, super. External, internal project selection, super. Racimetrics, responsible, accountable, consulted, and informed, very good. Communication plan also we discussed. Super, super. Measure phase. What is the tagline of measure phase? Whatever we cannot measure, we cannot improve. Very simple, right? See, these are the concepts we need to start implementing in our day-to-day processes, day-to-day life. Okay, then it will, you will become, yeah, statistics. What is statistics? It's a science which converts data into information. Yeah, we discussed about SWOT as well: strength, weakness, opportunity, and threats. Okay, this strategic tool basically, through which we can identify the projects. Wherever there is a gap, we can identify the projects. Okay, very good. What else? What else? Yeah, mean, mode, median. Fantastic. So I think 86% is very well recovered. Let's start. So we are in the measure phase. Yesterday we spoke about the statistics. Okay. Yeah, one more thing. If you remember descriptive inferential statistic, how many of you remember? Continuous and discrete data. Very good. Range variance standard deviation. Yes, this was missed out. Yeah, discrete data, continuous data, the descriptive statistic, inferential statistic. Remember that? Very good, very good. Super. Chalo, आगे बढ़ते हैं. So there is a concept called, when we collect the data, there are two things before we start the Minitab exercises. There are a couple of things I would like to cover today. The first thing is operational definition. Let me quickly explain this. What is operational definition? You can just make a note of this. What is operational definition? Operational definition is, for example, let's say in the aviation industry, I give this example regularly. Let's say there are four aviation companies. One is Air India, other is Indigo, let's say Akasa, and which one? SpiceJet, let's say. Okay, so let's say there are four, aviation companies, the airline companies. Now, the aviation ministry wants to check which airline is, is delivering very good on, on the point, what you can say, takeoff. Okay, on time takeoff, let's say. So they ask the data from all these airlines, right? So Air India says, so they ask the question first, how do you calculate? Air India says the moment the planes pushes back because the plane is parked in the parking bay, right? When it is not flying, it is parked. So when it is pushed back, when the reverse gear is applied by the captain, and then it starts pushing back. So Air India says, I'm just giving you example, okay? So Air India says that is our takeoff time. Okay. Then Indigo says, no, the moment it starts taxing towards the runway, that is my takeoff time. Akasa Airlines says, no, the moment it reaches the runway, okay, that is the takeoff time. And let's say SpiceJet says, no, the moment it takes off, the wheels takes off from the ground, that is actually the takeoff time for us. So all the four companies are measuring the takeoff time differently. So we cannot compare apple to apple. It will be apple to orange. So we need to define a standard method of collecting the data. Then only it is possible to compare. And that is done through operational definition. Okay. What is operational definition? We define what data needs to be collected. When, what will be the frequency? Okay. Where that data has to be collected. All right. Then why also you can clarify. All right. And then how. And by the way, who also before how it will be who would collect the data. So all these details are written down and how the data will be collected. So all these details would be written down in a document, in a statement, and that is called operational definition. So it becomes standardized. Let's say, for example, if we are doing a project and our team members are in different shifts, there also their understanding might be different about data collection, right? So to maintain that standard, we need to make first a operational definition. What data needs to be collected, when, where, why, who, and how. So all those points which are clarified in the definition, that is called operational definition. Now, once that is done, then there will not be any misunderstanding, miscommunication between the data collection entities or the processes or people. Okay, just to avoid the variation or remove the variation from the data collection process, operational definition is used. Are you clear with this? Just give me yes in the chat. So this is the first thing before we go for data collection, we do operational definition. Are you clear? Just give me yes. So operational definition is, okay, is it, yeah, can you just check the, okay. Everybody, yeah, good. See, we have kept the process, the chat into host and panelist. So that's why it is not visible to everybody. Okay, but everybody is giving me yes. The second part is called as measurement system analysis. Okay. After operational definition, there is second part, which is called as MSA, which is measurement system analysis. Measurement system analysis. So let me write MSA here in the center. MSA, measurement system analysis. Now, what is measurement system analysis? Okay. If you remember the 6 M's of Ishikawa: man, method, material, machine, mother nature, and there is something called measurement. Yes or no? Everybody? What is that measurement? Measurement meaning the variation coming from the measurement system. That is actually called measurement. And I think yesterday only I gave this example. Or in yellow belt also I gave this example. If you want to weigh yourself, okay, at your residence, let's say home, in your gym, and at your doctor, Just take your weight at the different weighing scales and you will see the variation. And this variation is coming from the measurement system. That weighing scale, whatever weighing scale we are using, different weighing scale, different weights are coming. So see, what is the ultimate purpose of Lean Six Sigma? Six Sigma to be precise. That if this is the variation, reduce the variation and bring the process in the center like this, right? So all our efforts are towards reducing the variation and bring the process toward the center by reducing the variation like this. So if the measurement system is generating the variation, we have to fix that as well. And that is done. That is quantified. How much variation is induced because of measurement system. So what is MSA? Measurement system analysis. So what does it do basically? It is used to quantify, make a note of this. It is used to quantify variation induced due to measurement system. So there is a technique in which, a statistical technique in which we basically quantify how much variation is induced because of this measurement system. Now, when we say measurement system, I gave you example of weighing scale. In your process, what kinds of measurement system do you have? Type in the chat box. In your process, what kinds of measurement system do you have? Yeah, think about it and type in the chat box quickly. Vernier, very good. Vernier calipers, screw gauges, thermometers, very nice. Weighing balances, very good. What else? Type in the chat box. Everybody, whatever measurement system equipments you have, type in the chat box. Very nice. Okay, screw gauges, thermometers, tapes, very good. Tapes is also measurement tape. Anemometer, okay. Superb. What else? What else? Type in the chat box. All measuring instruments for the manufacturing industry, yes. PF meter, dial gauges, orifice flow meter, diometer, very nice, superb. So all these things basically come under measurement equipment. Now, any variation coming through this has to be gauged. Okay. Now, we have seen yesterday, there are two types of data, right? One is continuous data, other is discrete. Now, if you have continuous data, let's say continuous data, then we go for gauge R and R, GRR. And if we have a discrete data, then we go for attribute agreement analysis. What is that? Continuous data, we go for GRR, gauge R and R, or gauge repeatability and reproducibility. And if you have discrete data, we have already studied continuous and discrete data. What are the differences? Correct? If you have discrete data, we will go for attribute agreement analysis. Just like pass, fail, go, no go, male, female, that kind of data we have. Then we go for attribute agreement analysis. I'll give you just one example. Let's say for example, I want to measure the diameter of this pen. Is it continuous data or discrete data? Type in the chat box, C or D. Type in the chat box. I want to measure the diameter. If I take vernier caliper and start measuring the diameter, C, continuous data, right? Now, second example I'm just giving. I'm a banker. I'm working in a loan department. GRR. GRR is gauge repeatability and reproducibility. Gauge, G for gauge, R for repeatability, and second R is for reproducibility. Okay, I'll explain you quickly, briefly. And AAA का full form है attribute agreement analysis. Attribute agreement analysis. In the green belt level, we have just an introduction to this. In the black belt level, we have the practical applicability of it. Okay, so that's the difference. So I'm just introducing the MSA to you. Coming back to, I'm a banker in the credit loan department. Okay. So I am receiving the application file I'm accepting the file or rejecting the file. What kind of data is that? C or D? Very good. Super. Correct? Amazing. So you guys are clear, right? Continuous and discrete. So this is a discrete data. D for discrete, correct? So if you are having continuous data, you go for GRR. And if you are having discrete data, you have attribute agreement analysis. Now, MSA is mandatory for automotive segment. Measurement system analysis is mandatory tool used by automotive segment. There is a global body called AIAG, just for your information. AIAG stands for Automotive Industry Action Group. It is a group of the big US based automotive OEMs, the companies like Fords and Chryslers and General Motors and all those big players of US. All right. There is a German counterpart where Mercedes and BMWs and Audis and all those German counterparts are there. So their body is called VDA. So these two bodies, basically, AIAG is accountable to develop the standard, just like quality management system, like QMS, ISO 9001, etc. So there is a quality management system, ISO body, right? International Standards Organization. So that body is basically accountable to revise the standards, update the standards, documented everything. All right. So AIAG stands for Automotive Industry Action Group. And VDA is a German pronunciation. So that need to check. Okay, VDA is a German word. So that German pronunciation is different. Okay, but we can find it out on ChatGPT or Google. Okay. So coming back to this. So these people define the measurement system analysis, this one. Okay. Now, let me quickly. So for the continuous data, what we do generally. So according to AIAG, what they say, if you want to, let's talk about GRR first. Okay. Okay. Now, if you want to do any gauge study, at least you should take 10 samples. How many samples? 10 samples. Okay. Understand this. Let's say, for example, I want to check the diameter of this pen. So I should take at least 10 such pens. Okay. Yeah. So AIG basically is a automotive body, automotive industry action group. So their role is to define, it's a governing body. Okay. Just to define all the quality parameters, all the standards required for the automotive industry. Okay. That's the basic role of AIG. Okay. It is formed by the US based OEMs of US based. And there is a counterpart of German based because which is very good. Verband der automobile industry. It's a yeah. Thank you very much, Deveshi, for this. So this is the basic understanding of this. Okay. Anyway, coming back to, so you should have 10 10 samples minimum. Then you should have 3 people to do this study, at least 3 people. What is the logic behind 3? Generally, we have in the industry, we have 3 shift operations. And let's say you are having quality people. So every shift you have quality people, right? So all of them should be on the same page. That's the logic behind the 3 people at least you should have. Okay. And for every sample, every person should take 3 readings. Example. Let's take example. Okay. I take the pen. So I'm just measuring the diameter. I have a vernier caliper with me. So I'll just put vernier caliper and measure the diameter. Okay. So my first reading has happened. After some time, the same pen will be given to me and I will measure the diameter. After some time, the same pen will be given to me. I'll measure so I will measure for every pen. I will measure 3 times. Okay. So I will write 3 trials. So you have 10 samples, 3 people and 3 trials for each. That makes it 90 samples altogether. Now, when we take 90 samples, yeah, that is what is the standard they are saying. Okay, that's the best practice scenario defined by AIG. Now, Once you feed that 90 sample data, 90 data points in the software, software will give us a GRR score. Okay. So this GRR score, which is gauge R&R score, if that GRR score is between so see, there are two parts. One is GRR as well as AAA, right? So it should be between, 0 to 10%, it is the best. Between 10% to 30% still acceptable. And 30% above variation, if you have, then you can reject it. Reject the, what I can say, this system, measurement system, because there is a too much variation. Okay. Up to 10%, we can expect that much of variation because of measurement. Okay. That is acceptable. Up to 30% is still, so see, up to 10% is the best. That means it is amazing thing. Up to 30% still acceptable, but above 30% we can reject. Similarly, if you have discrete data, okay, then there is something called kappa value. Kappa value. And similar to this kappa value also, you have between, what you can say, 1 to 0.9, it's the best system. 0.9 to 0.6, you can still accept. And 0.6 and below that, below 0.6, you can reject. Okay. So this much of information in the green belt level is okay. So we have to collect the data, put that data in the Minitab and check whether it is acceptable or not. Once it is acceptable, then we can proceed further. Okay. So this much is covered in our green belt curriculum. Yes. Yeah. Kappa value is just like GRR value from continuous data, GRR in case of AAA, the software will give us a kappa value. Okay, so kappa is actually there was a statistician called Fleece. Okay, so according, see, kappa is just like alpha, beta, theta, gamma. Kappa is just like a Greek letter, alpha, theta. So kappa is one Greek letter. Okay, so they say kappa value. So Fleece is kappa value. That's what they say. So range is 1 to 0.9. Okay, which is the best kappa value. 0.9 to 0.6 still acceptable. Below 0.6, you can reject it. Here. And this is called measurement system analysis. Clear, everybody? Now, let me just quickly, this much is information is enough for the green belt level. Let me quickly explain you repeatability and reproducibility. Okay. Just for our understanding. Even though when we'll go in the black belt level, we will cover much detailed. But what is repeatability? And what is reproducibility? And how do you remember this? Okay. Now, what is repeatability? Let's try to understand. Repeatability is same sample, meaning same, let's say pen you have taken, plus same equipment, the same vernier caliper you have to use, and the same person. You can make a note of this. I'll explain you this. Okay. Against what is reproducibility? Same sample plus same equipment, but different person. Okay, for example, let's say I take the pen, same vernier caliper, I will check the reading, let's say 10.1. Okay. Then I will take the same pen after some time and I will check the reading myself. If it is 10.1 only, then it is repeatable. The ability to repeat the same reading of the same person is called repeatability. Clear? Repeatability meaning ability of the same person to repeat the same values. It's called repeatability. What is reproducibility? Now let's say Dhiresh has checked 10.1. Let's say Dhiresh gives this, the next person is Suresh. If Suresh also checks 10.1, That is called reproducibility. Same sample, same equipment. If Suresh also gives 10.1, that is called reproducibility. Now people get confused. What is repeatability? What is reproducibility? How do you remember this? How I remember this is very simple analogy I use. Okay, now this is never taught in any Lean Six Sigma course, or this is only my logic which I'm just explaining. Now, as a human being, to reproduce a baby, we need two people, yes or no? A male and a female, correct? Right? So to reproducibility, associate that with different people. Understand this. To reproduce a baby, we need different people. Similarly, reproducibility ke liye, remember different people. So once you register this, then repeatability is the same person giving the reading. Reproducibility is two different or three different people giving the same reading. Are you clear with this? Just give me yes in the chat box. Clear this analogy? This is called repeatability and reproducibility. Okay. So this much of measurement system analysis. Once MSA is done, once operational definition is done, then we are all set to collect the data and do the analysis of the data with the help of Minitab. Okay, everybody clear? So this much of the theoretical part in the measure phase we have covered. Now we will jump into the the Minitab part, which is the analysis part of Minitab. Okay. Now tell me how many of you have Minitab right now available with you? Just type me in the chat box. Yeah. If you don't have Minitab right now with you, then that's what I said yesterday only. When you come tomorrow, make sure that Minitab is available with the laptop and Minitab install, right? Yeah. If you want any assistance, please send a message on the mentor's number and they will support you on that. Okay. Let me just yeah, I would just suggest my team. Just a second. Let me type. I believe everybody has the mentor's number, right? Okay, can you just send a message that please send me Minitab details, Minitab installation. All the new members, especially if you don't have Minitab, just send a WhatsApp message that please share how to access Minitab. Okay. Now, for Minitab, you should have at least a window-based laptop or a desktop. Mobile pe nahi chalega. It's a little heavy software. So yeah, very good, very good. The people who have it, they can perform along with me. That's the advantage of Minitab. Okay, team. The people who are sending the messages, kindly guide them for the Minitab application. Just give me a thumbs up. Team, can you just give me a thumbs up quickly? Okay, thank you very much. Super. So let me just share for the people who have Minitab right now. So we will just start with Pareto chart. So I'm just dropping a Minitab file in the chat. If you can quickly download it. Okay, if you, for any reason, if you don't have Minitab or not able to download this file or whatever it is, right? Just observe whatever we are doing. Okay, this is the same file. I've just dropped it twice. Okay, once you have opened the file, let me know that file is open. Okay. Once you open the file, please let me know. Meanwhile, I've just opened the file. The data looks like this. Okay, I'll just wait for you guys to open the file. Just type open in the chat box once you opened it. Yeah. Now, if you have Minitab, yeah, Mr. Rocky, if you have Minitab installed, then only the file will open. Otherwise, it will not. I'm just dropping the file once again. The name of the file is example Pareto chart.mtw. MTW is Minitab worksheet. Okay. Yeah. Opened. Very good. Very good. Chalo. If you don't have Minitab, don't worry. Just observe this. Okay. Means instruments, variability. Yeah, both. Anuj, that's a very good question. That's a very good question. So what Anuj is asking is MSAs done for instrument or the people? So measurement system is combination of instrument and a person who is actually operating. Okay. So it is for both. That's why it's called repeatability, reproducibility. Repeatability is measuring the variability coming from the person itself. Meaning, so repeatability meaning repeatability is actually the otherwise. मैंने उल्टा बोला. Repeatability checking the variation coming from the instrument. Reproducibility checking the variation coming from the person to person. Okay, so they consider both a person as well as the equipment. Okay, and there are a lot of parameters which you can. For example, I'll just give you example. In one of our client, they make the PVC sheets. Okay, and the color is very important. Okay, now everybody's understanding of color is different, right? There are so many shades of the color. Okay, if you have red, there are so many reds. If you have blue, there are so many shades of blue. And there can be huge variation in the identification. So that also plays a very important role in the MSA. Okay. Now, so coming back to Pareto, here we have the data of there is a fruit exporter. Okay. And there is one consignment which is returned back by the customer, and that is the pitches consignment, and the data is like this. Okay, they found in the consignment 100 pitches were bruised. Okay, bruised मतलब वो दबे हुए या फिर मार खाए हुए, bruised. Okay, undersize 87, rotten सड़े हुए 235, underripe. Okay, पके नहीं है अभी तक, wrong variety and wormy, right? So all these are different types of the complaints they have received. Let's do the Pareto. So do the to do the Pareto, go to stat, quality tools, and Pareto chart. Just follow this path. Go to stat in the first line. Go to stat. Now see, understand this. There are a lot of options: file, edit, data, calc, stat, graph, editor, tools, window, help, and assistant. Okay, there are a lot of data options available, out of which, remember this, everybody remember this, stat is used for statistical analysis and graph is used for graphical analysis. These are the two options we will be using the most in green belt, black belt, master black belt, yellow belt, whichever belt you want. Stat is for statistical analysis, graph is for graphical analysis. Remember this. Okay, right? Not required. See, that's what I'm saying. I'm just giving you very shortcut to remember. If you're doing a statistical analysis, go to stat. If you're doing graphical analysis, go to graph. Okay. So right now we are going statistical tool, quality tool, Pareto chart. Okay. Now let's click on this stat, quality tools, Pareto. Now here in the defect column, just select the types of the defects. So it is there in the problem column, right? So double click on problem. And in the frequency, select pitches lost. And click on OK. Everybody got this? Just give me yes in the chat box. See, in the defect column, select problem. In frequency column, just double click on this. So you have to just double click on the left hand side. Okay. I repeat once again, just listen to this. You have this, you have the data. Go to stat, quality tools, Pareto chart. Stat, quality tools, Pareto chart. Click on that, you will come to this. Stat, quality tools, Pareto chart. In the defect, select problem. In the frequency, select pitches loss. Now here, very interesting. There is something called combine remaining defect into categories. Okay, there are two options. Okay. So this is by default, it is selected. Okay, let's say I'll show you both. Let's say I select do not combine. Okay, let's say we select do not combine and say okay. Look at this. Okay, I'll show you both the diagrams. See, what is the difference between both the diagram? Understand this. In Pareto chart, I don't see the options in Pareto chart. Okay, so what is happening right now is this. Have you reached to this window? Just give me yes, Mr. Rocky. Yes, okay. Now, let's say, let me remove this, okay? So, ऐसे होगा ना? Correct? So, the moment I click on this, just click on this defect. So, you will get problem and pitches lost appearing on the left-hand side. Just click on this. Just give me yes. No? Have you opened the same file which I have given? Hope you have opened the same file which I have given. Can you check the file? If you open the file, so you have to open the file. Now, see, for example, okay, which version of Minitab are you using? Are you using SNG's wala Minitab or some other version? Which version of Minitab you are using? Because these files are Minitab 17 files. Combine individual, which is very good. Deveshi. Let's same which you guys gave. Okay, fantastic. So, are you observing this file? ये फाइल आपको दिख रहा है? The file which I showed you, just showed in the chat. Yeah, can you just click on that? It will get downloaded. Can you just click on that? So if you open, once you open the file, let me know. Have you opened the file? First, you open the file. That's step number 1. First, you open the file, which will look like this. Just give me yes once you open the file. The file which I have given, then only it will come. It should have this, this data, problem, pitches lost, etc. Okay. Yeah, guys, just wait a while. So he's just a little behind. So let's take him together. Okay. Could you open the file? Please give me yes. Once you open the file, this will be appearing on your screen. Problem, pitches, slot, etc. Have you received the file first of all? In the chat, that's what we are saying. Okay. Can you just send hi on the mentor's number right now? Just right now on the WhatsApp. Can you send hi right now? Okay, let me just quickly go to the mentor's number. Can you share hi, send hi quickly? But I have doubt whether WhatsApp will take the data file. चेक करते हैं एक बार, ट्राई करते हैं, नहीं तो फिर सिर्फ आप ऑब्जर्व करिए. Just send me hi and I'll just share once. Just एक बार ट्राई करते हैं, अगर नहीं पॉसिबल है तो just observe what we are doing. एक सेकंड मैं सबके आंसर देता हूं. Let me first. Have you said send hi on the WhatsApp number, mentor WhatsApp number 99305 वाले? Is it Halak Ben? Is it? I have received Halak Ben's. Just a second, guys. A little delay because of. Yes. Okay. Chalo. So I've just shared the how to access the Minitab file as well. And let me share if I can share this file with you. Okay. Let me try if this file is. Can you just check? I've just shared that MTW Pareto chart file. ओके. जिनको फाइल मिलने में दिक्कत है प्लीज यू नो just observe whatever we are doing here. Okay. And then you can practice it later. हाँ, वो I think that is not supporting to WhatsApp. Okay. Anyway, see, all these files are there. I'll show you. मैं फिर से एक बार सबको दिखा देता हूं आपको फाइल्स कहां से मिल सकते हैं. Okay, everybody, just I'm just opening your green belt certification program course number 1. Let me share with you. Okay. From there also you can access all the files. From where I'm just sharing my screen right now. वहीं से मैं फाइल्स ले रहा हूं. All right, so listen to this. First, this is our green belt. Yeah. Okay, so everybody listen to this. This will solve everybody's problem. Listen to this. Okay, that's what I said. Be prepared, come prepared with Minitab. Okay, now here we go. So if you come to the major phase, because we are in major phase, okay, for example, here you can see Pareto chart. Okay, can you see here Pareto chart? Just give me yes. So in this 7 minute 33 second, there is a video to explain what is Pareto chart. Okay, yes, can you see this? Below that there is Pareto chart Minitab exercises. Can you see here? Just give me yes. If you click on start, everybody, you can, if you're not getting files from here, you can always go there and check the files. Okay, so these are the files you can download. Pareto chart, example, Pareto chart. So this file which I've shared, if you click on this, okay, and download it, the same file will get downloaded. Okay, any other file also gets downloaded, just same procedure has to be followed. That's it. थोड़ा data अलग होगा. That's it. ठीक है? Got it, everybody? Just give me yes in the chat box. Clear? So if you are not getting files, you can access files from here. Okay, now let me just come to Pareto chart once again. So this is a Pareto chart. In this, 80-20 principle is applied, where we have rotten, understand this, 235 fruits, the pitches were rotten, which is contributing 53.3%. Okay, bruised 100, so 22.7% contribution is bruised, and undersize 87, which is 19.7%. If we combine only these three, the combined impact is 95.7. So this is called cumulative percentage graph. So if I draw a horizontal line, this is 95.7. So 95.7 percentage contribution is because of three categories of this, defects. If we focus if we focus on this only and try to eliminate it, we can eliminate almost 95.7% of the defects of the pitches. Are you clear? And this is the crux of the Pareto chart. Are you clear with this? Everybody just give me yes in the chat box. Yes, exactly. While working, it will select the content. You just have to click on the, for example, if you are here in the worksheet, okay, I select quality tools, Pareto chart. Okay, if nothing is there, I remove everything. The moment I click here, defect, okay, so all the columns will get activated. So I have to just select which column I want to put. So first you select the type of defect, then you select the frequency type, okay? And you click on OK, and you will get a Pareto chart, all right? Now, just before we go to the next file, there are three important tabs we need to remember. Okay, just see my cursor on the top of it. See my cursor, there are three important tabs here. Okay, so there are three important tabs. I'm talking about these three tabs. The center wala tab is about the data. This file, the file which we are observing. On the left hand side, this is the statistical analysis. And on the right hand side, it is a graphical analysis. If you click on graphical wala tab, you will see all the graphs. Let's say right now we have made Pareto, right? So you will see the Pareto chart appearing in this folder, okay? And if you click on stat, now right now we have not done any kind of statistical analysis, okay? So once we do that, then this statistical tab will get activated and all the content you will see over there, okay? Let me show you that quickly. So if you click on graph, now can you see here the graph which we have just plotted? You can see over here. Okay. If you click on stat, there is right now nothing in the stat. It's a blank thing because we have not done any statistical analysis as such. What is statistical analysis? Statistical analysis just like the mean mode median, okay, or you have hypothesis testing, regression. All these things basically will appear over here. Okay. Clear, everybody? Just give me yes in the chat box. Clear hai? Yeah. See, it requires a little bit of practice. Okay. Is it entering commands? Which command? This one, right? Pareto chart of problem. So this is the command which we have given earlier. Okay. Now let me share with you See, initially, this is your day one. Let's say a lot of people who are asking the question, they are first time operating Minitab. Initially, it is overwhelming. Again, remember your day one of driving, day one of swimming, correct? So you compare with that. It was completely chaos. You don't know what is happening. But second day, it was improved. Third day, now you understand, okay, where to go, where to navigate. Okay, fourth day, fifth day, your confidence is more. Correct? So similarly, the same procedure is applied over there, right? Now, let me share with you another file in the chat. Okay. So only practice will make your life in Minitab easy. See, don't worry about it. It's not very difficult software to handle. It's very simple. Only it requires practice. Okay. Stat and graph. उसमें से practice करना है. Okay. So, let's open the file. Once it is opened, let me know in the chat. Have you opened the file? Let me know yes in the chat box. Yeah. Okay. So, I think what you can do is you have to update your Zoom. That also might be one of the reason why you are not getting why you are not getting the files in the chat. Okay, so शायद Zoom update का भी एक angle हो सकता है. This is what my guesstimate is, because all other people are getting the files, only you're not getting. Okay, so it is a localized challenge issue with the update. It's very simple, not to worry. You just have to go to Zoom and get the latest updated version of Zoom. Okay. Yeah, in earlier versions, these files, so Zoom was not compatible with all kinds of files. But now then the latest version of Zoom, now you can share any file, PDF, Word, PPT, Minitab. Okay. So this is just one example. Okay. Open. All right. So just try to understand. Okay. Don't worry. Just check whatever we are doing and you can just practice it later. I've already shown from where you can get the files as well. Okay. Chalo. So the data is chocolate weights in the first column. This is the data we want to check. So it's a simple chocolate weights, 42.1, 40.7, 40.3, etc., etc., etc. Okay. Now, the first thing we will do is statistical and graphical analysis. Okay. So let's go to stat, basic statistic, graphical summary. Just observe this, follow this path, go to stat, basic statistics, graphical summary. Stat, basic statistics, graphical summary. Yes, once you click on that, stat, basic statistics, graphical summary. This will appear. Just select the chocolate weight, which is the first column. Okay, just double click in the variable, just select, double click on chocolate weight. That's it. Don't do anything else. Click on OK. And you will get this diagram. Everybody got this diagram? Just give me yes in the chat box. Very good. Super. Now, what is the name of this graph? This graph is called what? This graph is called what? Type in the chat box. I hope everybody knows it. No, it is not Pareto. Pareto तो ऐसा दिखता है ना? See, Pareto is always like this, correct? Yes, it is histogram. What is that? It is histogram. Make a note of this. So histogram, the name histo and gram. These are two words here. Gram meaning graph. Make a note of this. Gram का मतलब होता है graph. And histo meaning historical data. So we have taken a historical sample data and we have made a graph out of it, which is called histogram. And from histogram, we get the normal distribution curve, bell-shaped curve, right? Right. So this is called histogram. Okay. Now this graph below the histogram is called as box plot. Make a note of this. This one, I'm talking about this one. Okay. Now you might not be aware of the box plot, but if I explain you like this, for example, in the box plot, this is the lowest value LV and this is the highest value HV. Okay, so this point is the highest value of the data set. This value is the lowest value of the data set. Okay, now remember this. This point is first quartile, or I would say Q1. This one is Q2 and this one is Q3, quartile 3. How many of you remember? And Q2 is nothing but median. How many of you remember yesterday's mean, mode, median? And quartile 1, quartile 2, quartile 3. Yes. So this is called as box plot. That's what I said. Tomorrow you will connect the dot. So box plot is another way of showing the same data set. So histogram can also be shown as a box plot like this. Okay. So see, box plot is, for example, we can use box plot for comparing multiple distributions. For example, let's say, okay, if the box plot is like this, I'm just giving you example. Against, there is a box plot like this. What are you observing? This is 1 and 2. There are two box plots I have drawn. What is your observation in this box plot? Type in the chat box. Wow, very good. So, very good. So the first and second, what is the difference? The second box plot is showing more variation, more spread of the data set. If I draw a histogram, it would look like this. Are you understanding? Just give me yes. So the same depiction in a different way. So comparing histograms will be very difficult, but comparing box plots like this is very simple. So we can compare multiple box plots, 1, 2, 3, 4, 5, 6, 10 box plots. That's why box plots are drawn like this. Okay, very good. Now coming back on the right hand side. So these are the graphical representation like histogram and box plot. On the right hand side, we see statistical data. Okay, now this is called as descriptive statistics. And this part is called as inferential statistics. Remember? Correct? Descriptive inferential. Yesterday I gave the example of 5 overs match, 5 overs score is a descriptive statistic. And inferential is the projected score is inferential, right? Similarly, remember mean, standard deviation, variance, number of data points, minimum value, first quartile, median, third quartile, maximum. We have learned everything. Only thing is that skewness and kurtosis we have not learned, which we will learn in the advanced programs. Okay, क्लियर? ये सब हम लोगों ने कल कवर किया था. मीन, मोड, मीडियन, variance, standard deviation, first quartile, second quartile, third quartile, everything. Correct? Now there is something interesting called Anderson-Darling normality test on the top of it. Now, Theodore Anderson and Donald Darling, these are the two statisticians. Their name has been given. Now, this test is shown whether the data is normally distributed or not. There are two types of data. One is normally distributed, and another is non-normal distribution. For example, normal distribution would look like this, and non-normal distribution will be like little skewed like this. Okay, so whether it is normally distributed, symmetrical distribution or not, that is statistically proven with this Anderson-Darling normality test. If the p-value, write this down, if the p-value is greater than 0.05, the data is normal. And if the p-value is less than 0.05, then the data is skewed. Write this down. Skewed. S-K-E-W-E-D. Skewed. Clear? So in this case, the p-value is 0.256. That is a clear indication that this data is normally distributed. It's a proof. Significant factor in sampling. Yeah, very good. Clear everybody? Just give me yes in the chat box. यहां तक सब कुछ क्लियर है? Okay. Now, when we go to the black belt level, I will show you what is this p-value. Of course, today itself, I will cover what is the p-value briefly. But when we'll go the advanced level, black belt level, we will manually also can calculate p-value. Manual calculation we will teach you. Okay. It is not required, but for your understanding. Yesterday, if you remember, we manually calculated standard deviation formula. Remember that before we close the session, we made that calculation manually. Why? Do we have to manually calculate? Never. But we should at least know it once. Okay. Correct. So this is called the graphical and statistical summary of the data. Clear? Now, in the same data set, now I'm here. Now I want to go back to the data worksheet. You remember I showed you the three data tabs here. The center one is data worksheet, left hand side is statistical, right hand side is graph, right? So I'm right now in the graph tab. So I want to go to the worksheet. So I'll just click here in the center wala tab. Then I'll come back to the data once again. Clear? Yes. So just have to click on that tab, this one. Okay. There is a short key as well, which is Control Alt D. Control Alt D. Also, you can press Control plus Alt plus D and you can come to the datasheet folder. Okay. Now, datasheet worksheet. Now, let's do a time series plot. Okay. With the same data, now we will do multiple graphs we will make. For the same data, let's make a time series plot. What is time series plot? Go to graph and make a time series plot. Can you see here? Go to graph and just from bottom, fifth option is time series plot. Okay, once you click on time series plot, select simple. By default, it is simple selected. Just select simple, click on OK. And double click on chocolate weight. Okay, and click on OK. I repeat again, go to graph, time series plot, simple by default select hoga. Select chocolate weight here and click on OK. You will get this kind of a graph. Everybody got it? Just give me yes in the chat box. Same file. This file is multi-purpose file. So we will use this file for all the further data analysis. Okay. Correct. So we need to, so more you go in the mini tab, you will be, what you can say, well versed with it. Okay. थोड़ा सा practice करने की जरूरत है. That's it. Every day, agar 10 minutes, 10 minutes, 15 minutes, just make 1, 2 graphs every day. That will also suffice. Okay. Now, observe this graph. Now, observe this graph and tell me what are your observations here? What are your observations? Yeah, easier than SPSS. Yeah. And strata. Okay, very good. Super. And this gives very less errors. No errors I've seen. I've seen a lot of other counter softwares which give a lot of errors in the analysis part. Anyway, coming back to this. What are the observations? Variation is very high. Very good observation. What else? Observe very closely. I'll give you a secret here. The moment you just observe the graph, after maybe 20-30 seconds, the graph start to speak with you. It will tell you what exactly is happening. It will give you the details of it. Zigzag hai, okay. Mean shifting hai, very good. That's a very good observation. Okay, now my observations are what you need to investigate. My first observation. Okay, I will draw a line around 50th mark here. Okay. And if you observe very closely, before that, the process variation is like this. And after that, the process variation has increased. How many of you have seen this? Just give me yes. How many of you have observed this? around 50th mark, you can see just type yes if you observe the variation shift in the graph. Yes, you have to observe it very closely because I've observed it multiple times. That's what I can easily visualize it. Now we need to ask the question, what change we have done around 50th after 48th mark that the variation has increased. So that y has to be identified. See, graph will give us questions, not the answers. And good questions can do good investigation and good problem finding and the solution finding as well. So we have to find out the good questions from here. So this is my first question, why? The second question would be, why this peak and why these valleys are there? Why the high and low point? And are you observing? Look at this trend now. Just observe this trend. Look at this point. This point comes around, let's say 50th, 50, 52, 53 mark. After that, immediate next point is this. After that, immediate next point is very high. Similar kind of trend can you observe here? This is the lowest point. The weight is here around 38 grams. Because the chocolate weight is gram, right? And the immediate next point, the weight is approximately 46 grams. Immediate next reading. Can you see the huge jump, huge variation? Both these cases, huge variation can be observed. That means the moment you are changing something, which is, it's like, imagine you are driving on the highway and you have made a change in your steering, and now you are, let's say, on the right hand side, now you have your process shifted to left hand side completely. It's a very dangerous move, isn't it? So it can go let's say your what do you say, customer is having specification limit like this. Okay, this all is rejected, isn't it? If you have that much of variation, this all is rejected. So you need to investigate what is making that kind of thing. Okay. Plus, if you observe very minutely, you can see some patterns. For example, I'll show you the pattern, that then you will realize this. Okay. Let's say observe this. Huh? From this point till this point. Okay. Are you observing a zigzag pattern getting formed here going downwards? Are you observing? Just give me yes in the chat box. Here also you can observe a similar kind of a pattern. Zigzag and going downwards. Okay. Here you can observe a pattern going upwards. Zigzag and going upwards. So these kinds of patterns also you should be able to observe in the time series plot. The name itself is time series. So the performance of the process against the time and what kinds of variations it is bringing. And then you can investigate root cause analysis and find out. Clear time series plot, just give me yes in the chat box. Clear hai, just give me yes. Yes. In the cardiogram also, you see the, ECG. You see the variation like this. Absolutely yes. Very good. Very good. Grams will not be written. है ना यहाँ पे? Chocolate weight in grams. On the x on the y axis they have written no? Chocolate weight in grams. Yes. Here also time series plot of chocolate weight in grams. So whatever you have given the title, it will be shown in the graph. Okay. Now, one of the very important objective of measure phase is to find out what is my sigma level. If we want in dots, yeah, that will be too messy then. Okay, if you start putting the numbers in the dots, now you will not be able to read the graph. Okay, that's what it is not shown in the graph. Okay, because in the small graph, they have fit 120 data points. Okay, yeah, if you put the grams, the digits also, it will be too messy for you to read the graph. Okay, yeah. Now the objective, ultimate objective of your major phase is to check the current sigma level. What is current sigma level? Whether you are at 2 sigma or 3 sigma or 4 sigma or 4.5 sigma, 4.2 sigma, 2.2 sigma, what exactly sigma level you are in. Why? Because after improvement, we can compare with the present sigma level. After improvement, let's say you are at 2 sigma. After improvement, you should at least go to 3 or 4 sigma. That's the objective. Now, while finding out the sigma level, we should actually follow this sequence called S, N, and C. Everybody, please type SNC in the chat box. SNC. Just type SNC in the chat box. SNC. Let me explain you this. SNC. Okay. S stands for stability. N stands for normality. And C stands for capability. Just write this down, I'll explain. What is stability? Stability is nothing but control chart. Write this down. Stability is done with control chart. I'll explain you what is control chart. Normality is done with normality test, which we already done. Anderson-Darling normality test, AD test. And capability is done with the help of histogram, which I will show you right. Okay. So first we'll do control chart. What is control chart? If you remember, the control chart looks like this. Okay. There are 3 lines. Okay. Where the first line is the center line is the average line, and there are control limits. Okay. We will do it first. First we'll do stability. Normality we have already done. Still we will do it, and then the capability. Okay. So how do we do stability? Let me share with you. Go to stat, control chart. Everybody follow this path. Follow this path. Stat control chart, variable control chart for individual. Stat control charts, variable charts for individual. Just follow this. Stat control charts, variable chart for individual. Okay. Once you click there, once you click that, just select chocolate weight. That's it, and say okay. Wow. Everybody got this graph? Just give me yes in the chat box. If you observe, it is the same time series plot with 3 different lines plotted. Same time series plotted, same data plotted. But there are 3 different lines getting plotted. First is X bar. X bar is nothing but the average, the mean. This is called upper control limit. What is the formula to calculate? X bar plus 3 times standard deviation is upper control limit. And there is something called lower control limit, which is X bar minus 3 times standard deviation. Now, how it is calculated? Let me give you a simple data. Okay, we will calculate UCL and LCL. UCL is upper control limit. LCL is lower control limit. Now, what is that? Let me explain. Okay. First, we will calculate it and then we will explain. Okay. Imagine there is a data point where X bar is 42 and let's say standard deviation is 1. I repeat again. X bar is 42 and standard deviation is 1. In that case, can you calculate upper control limit and the lower control limit with the formula? X bar is 42, sigma is 1. I've already given you the formula. UCL is X bar plus 3 times standard deviation. LCL is X bar minus 3 times standard deviation. Can you just calculate, give me the answer quickly? I'll just wait for you. I will not calculate myself. UCL is 45 and LCL is 39. See, I've just shown you random numbers, okay? How sigma is 1, etc. I've just then given this random numbers. LCL is 39, UCL is 45. Everybody got the same answer? Just give me yes in the chat box. UCL is 45, LCL is 39. Okay. Similarly, they have calculated this upper control and lower control limit for this. For our simplicity, I have just shown you this rounded off number. Are you understanding this? The same calculation software is given because for us, for software, they have some decimal numbers, 1.12 or 1.23, etc. Just to make it simple, I've just given the rounded off number. Okay. Now, see, there was a statistician called Walter Shewhart. Make a note of this. Walter Shewhart. 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 Shewart. Shewhart. According to Walter Shewhart, any process, understand this, any process which runs between plus and minus 3 standard deviation, if the variation does not go beyond plus and minus 3 standard deviation, that process is called as a stable process. Stable process. Yes, it is common. Plus 3 and minus 3 standard deviations are common. Okay. Okay, let me revisit this. According to Walter Shewhart, any process which runs between plus 3 and minus 3 standard deviation, which is nothing but upper and lower control limit. If your all data points are within upper and lower control limit, then the process is called as a stable process. Now, what is stable process? It is predictable process. Stable meaning predictable. Just like, for example, there is a child who is stable child, for example. Stable meaning that the child will wake up exactly at 6 o'clock, get up, will get himself ready at 7, will go to school, come back at 12, go to study at 1. It is predictable behavior. Against another child, sometimes that child will wake up at 6:30, sometimes 7 o'clock, sometimes 5:30. There is a variation. Are you understanding? So what variation is stable variation and what variation is unstable variation? That is, something which is very important. Okay. Yeah, Kiranji, we are going to take a break in next 5 to 7 minutes. Okay. Yeah, we'll take a break after this. After there are a couple of points I will cover and then we'll take a break. Now, so according to Walter Shewhart, any process which runs between upper and lower control limit, it's called a stable process. Okay. Now, if you observe very closely, only one data point is just touching this boundary. Otherwise, this process we can say is a stable process. Okay. So this variation within the control limit, this variation is called as common variation or common cause variation. What is common cause variation? Every day we come to our office 5 to 10 minutes here and there, right? Plus or minus 5 to 10 minutes. It is a common traffic, common rush, common delays, common variation in preparation. That is called common cause. But let's say one fine day, we have our tire puncture or maybe a big accident on the road. And on that day, we come 1 hour late. That is called, if let's say there is one data point which goes beyond this, that variation is called as special cause variation. Are you clear with this? Just give me yes in the chat box. When there is a special cause variation, that process is unstable process. It is not stable process. Are you clear? Any process having only common causes is a stable process. Any process having special causes is unstable process. Clear? Just give me yes in chat box. And this is called as a stability check. Clear hai everybody? Very good, very good. So this is the most commonly used control chart, which is called as individual chart. I chart stands for individual. Okay, this one you can see here, I chart. There are other types of charts as well, which we are going to study in the control phase tomorrow. Okay. And non-probabilistic sampling, we can do that. We can do that. But right now, I'm just talking about the the common cause and special cause variation of the stability of the process. Okay. Yeah. Clear hai? So this is how the stability checked. Normality, we have already seen the p-value, right? If you remember, if I go to graph and I go to summary report, you remember this p-value 0.256. This is a normality test. So this is the data is stable as well as normal. Now we are ready to check the process capability. Remember, S for stability, N for normality, C for capability. Now to check the capability, we need specification limit. Now what is capability? What do you mean by capability? Or rather process capability. Okay. Process capability is nothing but ability of the process to satisfy customer requirement. Make a note of this. What is process capability? Ability of the process to satisfy customer requirement is process capability. So let's say our customer requirement is between 44 and 40, let's say, for example. Okay. If customer accepts the product between, or let's say 39 and 45, example. So this is my lower specification limit and upper spec. Now these are the two specification limit and not the control limits. Understand this. There is a difference between control and the specification limit. What is the difference? Control limit is decided by the process. Specification limit is decided by the customer. Clear? Okay. So these are specification limit. Let's say customer says, I will accept the chocolate between 39 and 45. Okay. Now we will check the process capability of this process. Okay. How do we do that? Go to stat, quality tool, capability analysis, normal. Just follow this path. Stat, quality tool, capability analysis, normal. Stat, quality tool, capability analysis, normal. Okay. Click on that. In the single column, select chocolate weight, double click on chocolate weight. And the next part is subgroup size. Now, what is subgroup size? Try to understand it. Some cases, we take group of samples. Okay, for example, if we take individual sample, individual chocolate one by one, in that case, subgroup size is 1. If instead of 1 chocolate, if we are taking 10 chocolates at a time to test, so our subgroup size will become 10. Are you clear? So right now we will keep it as only 1. Okay. Then comes to lower specification limit. It is 39. Upper specification is 45. I'm just giving some random numbers. Okay. Now don't click on OK yet. Go to option. Go to option. Option is there, on the right hand side, there is a third type, the transform, estimate, and option. Click on option. And here there is a small change we can do. There is something called CPPP and there is sigma level. Okay. Yeah, sample Y1 मैं बताता हूँ. Okay. just select sigma level benchmark Z. Just click on that and click on OK and click on OK. Now, before clicking on OK, what is subgroup size 1 meaning? See, imagine a factory of chocolate. Okay, imagine there is a conveyor belt. Okay, and ये सब यहाँ से chocolate आ रहा है. And you are a quality person who is a checker of the quality. Now, if you are taking one sample, then your subgroup size is 1. For testing the weight, if you are checking one sample, then your subgroup size is 1. If instead of one sample, you are taking, let's say, 5 samples together, then your sample batch is of 5. So our subgroup size is 5. Clear? Yes, single or batch, exactly. Got it? Very good, very good. Super. Now coming back to this, once you enter all the data points, then click on OK, and you will find this. Everybody got it? Just give me yes in the chat box. So here, you can see, got it? Now, you can see the Z bench value, which is 1.74. If the Z bench value is 1.74, that means our current process is 1.74 sigma process. See, when we say 6 sigma, na, that 6 number is the Z bench value, Z bench. Okay, so currently it is 1.74 and we want to improve it by improving our process. Are you clear? This is called process capability analysis. Are you clear with this? Just give me yes. So we have covered stability, normality, and capability, all these three. See, initially, it seems a little difficult to understand. But again, I said, just have to practice it few times to got it. Okay? Yes. Kiranji, what do you want me to repeat? I repeat once again. This entire process. Okay. So we are here at the sample. Now we'll go to stat, quality tools, capability analysis, normal. Okay. Then let's say here we will select chocolate weight, subgroup size 1, specification, lower specification 39, upper specification 45. Go to option, select benchmark Z, which will give a direct sigma level, and click on OK, and you will get this value. Clear? We will reduce the bell-shaped curve. Exactly. Okay. So what is our end objective? The moment we will work on the variation, the data will come very close like this. Okay. So that less number of data points will go outside the specification limit, and our Z bench value will be, let's say, 4 sigma. So from 1.74, it will move to 4 sigma like that. That is the ultimate objective we have. Clear, everybody? Just give me yes in the chat box. Super clear? So on this note, we will take a quick break. Okay. Yes, we can work on the multiple data sets. Yes, absolutely yes. But at the green belt level, we will cover the basic fundamentals. Okay. Yeah, this is our current Z score. So our current process capability is 1.74 and our objective is to, so we will do the same exercise after improve phase. Control phase में हम लोग फिर से exercise करेंगे so that we can see the improved version of it. Okay. Super. So it is 8:31 kind of thing. We will be back by 8:40 sharp. Okay. Let's take a break of 8 to 9 minutes and we'll be back by 8:40 and we'll start the analyze phase. Okay. Analysis phase में हम लोग चालू करेंगे. ठीक है? Super. Okay, once you're back, just type I'm back in the chat and we can start our session. Everybody can just put them back. Yes, can we have the confirmation, please? I hope you could get enough time to grab your coffee or tea. Chalo. I've got few confirmations. Thank you very much. Thank you very much. Put, I'm back, I'm back, I'm back. Everybody. Super. Now, let us quickly touch upon the next important part, which is analysis phase. Okay. See, here we are talking about Lean and Six Sigma together. All right. So it is a combination of Lean tools as well as Six Sigma tools. When it comes to analyze phase, okay, we have two doors, I would say. Okay, two doors get open. One is a lean door. Okay, we also call it as a process door. Lean or process door. And on the other side, it is Six Sigma and data door. So in analysis, what is the objective of analysis phase? To find out the causes and root causes. In define phase, what we do? We define the problem. Project charter, team building, the stakeholder management, communication plan. So we freeze our problem. We document our problem. Measure phase, we collect the data. With the help of Minitab, we extracted information out of the data. In analyze phase, now we are moving towards the causes and the root causes of it. Okay. So here, for our understanding, if I have to divide the DMAIC, understand this. This is very, very interesting. Okay. So everybody knows y is equal to function of x. Just give me yes in the chat box. Everybody understands y is equal to function of x. Y is the output, which is depending on x, which are the inputs, right? Everybody knows this basic, correct? So our define and measure phase, we focus on y. And analyze, improve, and control phases, we focus on x's. Write this down. It's very interesting analogy. Nobody will tell you this. Define and measure phase, we focus on y, the output. We will collect the data of the output. What is output, by the way? Output is our project, what we are doing. It can be attrition, it can be downtime of the machine, it can be average call handling time, it can be quality, it can be customer complaint, whatever project we are doing, exactly, project Y. So data, so we will document project Y, we'll collect the data related to project Y in the define and measure phase. Now in analysis phase, our process focus shifts to the reasons, the causes, the factors, causes, root causes. Okay, that's where these two approaches comes into picture. Lean approach is all about, we use process maps. Now understand this, in hackathon, we are not going to cover the topics which are very easy to understand or, it is already explained. But I will give more time in hypothesis testing regression. For example, fishbone analysis. Shall I spend time on fishbone or shall I spend time on hypothesis? Just type F or H. F for fishbone and H for hypothesis. Type in the chat box, everybody. H, obviously H, because fishbone you already know, right? Fishbone analysis you already know, 6M's, man, machine, method, etc. Correct? So I would rather spend more time on something which requires more explanation, requires more in-depth analysis. Okay, that is something I would focus more today. All right. Now, but here let's try to understand this. Lean process contains the tools like process mapping. Have you heard about process mapping? Just give me yes. Have you heard about process mapping? Just give me yes. Okay, there is something called value stream mapping as well, VSM. Okay, yeah, value stream mapping, very, very important tool. Then VA, NVA analysis. Now this I will cover tomorrow. Value add, non-value add, I will cover tomorrow. Okay, apart from that, Teamwood, we all know Teamwood, yes or no? Correct? Transportation, inventory, motion, all those things. So that lean related analysis. Now, when do we use lean tools? Whenever we are talking about time related project, speed related project. Time meaning delivery time, downtime, your changeover time. Are you understanding? So wherever there is a time, you want to reduce the timeline, lean process tools will be applicable. When it comes to quality, variation, complaints, defects, rejection, all these things, Six Sigma related tools will be applicable. Now, when it comes to Six Sigma side, we have fishbone, which is fishbone diagram, FBD. We have root cause analysis, which is YY analysis. And after we find out the root causes, then we validate. So that there is something called validation. And validation happens through hypothesis testing and regression. And we are going to cover hypothesis and regression in this case. Today, I will just touch upon this basic fundamentals of hypothesis and regression. Advanced hypothesis and regressions are covered in the black belt level. Okay. So basic hypothesis, what is hypothesis testing, how it is done, etc. All this, the basic stuff we will cover. We will do a Minitab exercise as well along with this. Are you clear with the structure of analysis phase? Just give me yes in the chat box. So we will just touch upon hypothesis and regression today before we close the session. Just give me a quick yes. All right, good enough. So lean and Six Sigma, both tools are different in analysis phase. Okay, so let's talk about hypothesis. So you see the sequence. In the FBD fishbone diagram, we collect the primary causes. In root cause analysis, we find out for every primary cause, what is the root cause of it. Okay, once we find out the root cause, okay, then we need to validate it. Example, I'll give you example. How many of you believe that more experience of the people, let's say for example, most of us will believe that more rejection is because of lack of experience of the team. Yes, most of us believe this. Just give me yes in the chat box. One of the factors is lack of experience. More rejection, more defect is coming because of lack of experience. Yes or no? Everybody, can you just give me yes or no in the chat box? Now, what Six Sigma says, this is your opinion. Does data support this statement? Are you understanding? See where I'm coming from. When we do cause and effect and YY analysis, still that is your opinion. Are you understanding? The Titanic was sailing very fast. That is your opinion. What was exactly the speed of Titanic? Do we have the supporting document? And what speed is not acceptable? What speed is safe? What speed is not safe? Like while driving, on the highways, we have the marks, 80 kilometers, 60 kilometers. What is that? That is the highest speed limit. When there is a density of traffic, then you have 40 kilometers, etc. Right? So that is the limit. So we have to basically should know what is the limit, what was the actual data, and then not the opinion. Okay, so FBD and RCA, we will have the opinion. Those opinions have to be validated, and that validation is done through hypothesis and regression. First, we'll cover hypothesis. Hypothesis itself means, assumption. Okay, and hypothesis testing is testing your assumption with the data. That's it. Okay, so I always give this example of Sachin Tendulkar. How many of you have heard this Sachin Tendulkar example in the yellow belt? Just type me in the chat box. I recently stopped giving this example, but have you heard this example from me? Okay. Yes. Okay. A lot of senior people have heard about it. Okay. So all the new members, you would have heard about Sachin Tendulkar. Now, of course, he is retired almost more than 10 years now. But when he used to play one-day cricket, there was an opinion that whenever Sachin makes the century, India loses the game. How many of you have heard this before? Just type me in the chat box. Yes, a lot of people have heard this. Now, this is our hypothesis. This is our opinion. This is what our hunch. But what is the stat? According to the statistic, out of 49 centuries in one-day cricket, only 12 matches India lost. And you know what is his counterpart, Virat Kohli? So this is, let's say, Sachin Tendulkar. Virat Kohli's stats look like this. Out of 51 centuries right now, 10 matches India has lost. So can you see there is no much difference between the statistics, but we never say whenever Virat makes a century, India loses a game. Understand the difference? So this is called hypothesis testing. Okay. So coming back to, there are two types of hypothesis. One is called null hypothesis and other one is called alternate hypothesis. Null is denoted by HO and alternate is denoted by HA. Null is basically statement of equality. Just write this down, I'll explain you. Statement of equality, and alternate is a statement of difference. Statement of difference. Statement of equality and statement of difference. Okay. Now, what is statement of equality? Let's take example. Okay, let's take example. There are two vendors. Okay. Or let's say we're talking about Sachin Tendulkar and Virat Kohli. Let's talk about cricketers. Okay. So yesterday I spoke about Rishabh Pant and KL Rahul. Let's take the same example. Okay. Now Rishabh Pant and KL Rahul. Let's say P for Pant and R for Rahul. What we are saying, the average of Rishabh Pant and average of KL Rahul are same. That is called statement of equality. And alternate meaning, we assume that there is a difference. Okay. So what we'll do, we'll collect data points. Now, how many minimum data points we should collect before taking the average, standard deviation, etc. How much minimum data points we should collect? Type in the chat box if you know about it. How many minimum data points we should collect before we calculate standard deviation, mean, mode, median, whatever. 30, write this down. 30 data points. When it comes to data points, minimum 30 data points you should have. Otherwise, you should have 1 year data, but minimum 30 data points you should have. Understand this. This is for the project. Problem statement, you should have at least 1 year data. Okay. Now, let's collect the collect the data of 30 last innings. Okay. So X bar of Rishabh Pant and X bar of KL Rahul. Okay. X bar is average, right? So null hypothesis will say X bar of Rishabh Pant is equal to X bar of KL Rahul, and alternate hypothesis will say X bar of Rishabh Pant is not equal to X bar of KL Rahul. Then we will collect the data, put that in the software called Minitab, and Minitab will tell us which statement is right. Okay. Now, here is the question. Simple question. Imagine Rishabh Pant's average is, understand, now this is very interesting. Rishabh Pant's average is, let's say, 30 and Rahul's average is 32. There is a difference of 2 runs per innings. Okay. Now there is a mathematical difference which is clearly visible. No? Why do we have to go for null hypothesis, alternate hypothesis, and hypothesis testing? How many of you have this question? We can just collect the data, average, and compare. Na? What is this null and alternate? How many of you have this question? Just type me in the chat box. समझ में आ रहा है मेरा question? समझा? See, we want to compare the means, right? Means meaning the averages. Now, average, you can take the 30 data points. Okay. Last 30 मैच का एवरेज लेट से ऋषभ पंत का है 30. ओके. एंड केएल राहुल का एवरेज है 32 रन्स. ऋषभ पंत का 30 रन्स. ओके. नो इट इज क्लियरली विजिबल केएल राहुल एवरेज इज ग्रेटर. उसमें क्या सोचना है? उसमें स्टेटमेंट ऑफ इक्वालिटी, स्टेटमेंट ऑफ डिफरेंस एंड नल हाइपोथेसिस एंड दिस एंड दैट, व्हाट व्हाई इट इज रिक्वायर्ड. नाउ अंडरस्टैंड दिस. Yesterday, I spoke about descriptive and inferential statistics. Remember? Descriptive is about the sample and inferential is about the population. Are you understanding this? Now, this mathematical difference, I repeat again. How many of you remember descriptive and inferential? Let's recollect this. 5 overs is descriptive statistics. And projected score is inferential statistics. 5 overs is a sample, 20 over is a population. Yes, everybody remember this? Just give me yes in chat box. Remember this? Here, now what we are saying, we are taking 30 data points, 30 sample, 30 innings sample data, and mathematically, descriptive statistics says the average of Rishabh Pant is 30 and average of KL Rahul is 32. Now, what we are doing in alternate is, for a longer run, if this difference of 2 runs, is it statistically significant? What is the terminology I've used? Is it statistically significant? Significant. Significant. Okay. FICANT. Okay. Significant for the long run. There is a small difference, but is it significant difference for the long run, for the population? Let's say if I take 100 matches, will this difference be very significant between these two batsmen? That is what we want to check with this hypothesis testing. Are you understanding this? Just give me yes in the chat box. There is a mathematical difference, but is this mathematical difference statistically significant for the long run, for the population? That is what we are finding out in the hypothesis testing. Are you understanding? Just give me yes. Actually, it's very simple to understand. Okay, but I'm just clarifying all this confusion out. Clear hai yahan tak? I will make it super simple. We will do a minute of exercise as well. Clear hai? Okay. Now, very simple. So we will collect the data of 30 data points, put it in the software. Software will give us a value called p-value. The same p-value we have seen in normality test. Remember 0.05? How many of you remember that? Okay, p-value 0.05. So, understand this. In this case, if the p-value is less than 0.05, we reject null hypothesis and accept alternate hypothesis. If the p-value, so what we have done, we will collect 30 data points of Rishabh Pant, 30 data points of KL Rahul, put that in the software. Software will give us a p-value. P-value, again, what is p-value? How it is calculated? We will check it in the black belt table. Manually, we will calculate p-value. Manually. Okay, in the live hackathon itself, we will calculate manually. Okay. Anyways, coming back to this. If the p-value is less than 0.05, we reject null hypothesis. If the p-value is greater than, we accept null hypothesis. So how do we remember this? Very simple rhyming. Everybody, the rhyming is this. P low, null go. Everybody type this rhyming in the chat quickly. And write this down in your notepad as well. P low, null go. You have to remember only this much. P low, null go. That's it. Okay. Now it seems a little difficult to understand. कुछ समझ में नहीं आ रहा है. Don't worry, I will share with you one file right now of Minitab. Okay, इसको Minitab में करके देखते हैं. It's very simple for us to understand. And then we will see the practical applicability of it. चलो ये फाइल ओपन करो Minitab का. Once you open the file, let me know. File is open. The same file. I'm just giving the file twice, just in case if you have not received the first file, there's a second file. There's the same file shared twice. Okay. Yeah. Once you open this, P low, null go. P value is greater than equal to 1. 1 is 100%. 0.05 meaning 5%. Greater than equal to, I guess, alternative. So see, let's say P value is less than, if P low than 0.05, let's say P is equal to 0.05. Also, it is not less than, na? So you cannot reject null hypothesis. Whenever P is lower than 0.05, you reject. See, the statement is what? Understand this. What is the statement? P lower than 0.05, you reject null hypothesis. When P is equal, it is not lower, right? So you can't reject null hypothesis, no? Ideally. And again, 0.05 is only 2 decimals. Now, software will give us 3, 4 decimals as well. So you can easily find out the difference. Okay. It's very 1 in a billion chance to get P value 0.05000. Okay. Clear, everybody? Got? Open the file. Just give me yes in the chat box. We'll quickly do the hypothesis testing. There is a standard process and there is a pilot process. Similar to this. Okay, so what is the background here? What is the background? Let's say, there was a process 1 and process new. Okay, process standard and process pilot. They have introduced some new changes to some new vendor, new process. Okay, so they want to check the weight. Imagine there is some product coming out and they are checking the weight coming from a standard process and weight coming from a pilot process. Pilot is under trial process. Okay, now they want to check whether is there any statistically significant difference between average of standard and pilot. Okay, so what they have done, they have taken the data from standard process, they have taken the data from pilot process. Now what we will do, we'll go to stat basic statistics to sample t-test. Just follow this. Stat basic statistics to sample t-test. Okay, as you guys are following stat basic statistics to sample t-test. See, when I say Z bench, right? Remember Z bench I spoke just a little while ago? That is referring to a Z distribution, which is nothing but a normal distribution. Understand this? Okay. Now we are talking about to sample t-test. Now this t-test is referring to T distribution. Now T distribution is a little flatter distribution like this. It looks like this. Because it has a little lesser number of data points. You can do the T distribution, you can use T distribution with less than 30 data points as well. That's the advantage. You can see here, we only have 22 data points. Sif 22 data points hamare paas hai, right? So you can use T distribution. If you increase the number of samples, the T distribution takes the normal distribution shape and that becomes Z distribution. Z meaning normal distribution. Okay, this is just for your information. You can just forget about it. Okay, everybody opened it. Very good. Now go to stat basic statistics to sample t-test. या एक बार इसको करते हैं, बाद में मैं रिपीट करता हूं. टू सैंपल t-test को सिलेक्ट करो and here both samples in one column. In the drop down we have options like each sample in its own column and summarize data. So right now we have each sample in its own column. So select this second option. Okay. Now in sample 1, select standard process, sample 2, select pilot process and say okay. Everybody with me? Yes? Okay, I'll repeat again. Go to stat, basic statistics to sample t-test. Okay? So this window will appear. Stat, basic statistics to sample t-test. यहाँ तक आ गए सब लोग? Just give me yes. Prabhakar ji, are you with me? Okay. Now in this, just drop down menu, select the second option which says each sample in its own column. First says both sample in one column. So if we have standard process and sample process in one column, then we would have selected first option. Okay, but right now we have both samples in its own column, right? Select this. Now in sample one, select standard, sample two, select pilot and say okay. The moment you click on okay, go option wasn't showing. Okay, let me just go back. Which option? Got it. Okay, got it. Okay, पे click करना. Okay. Just click on okay. Okay, now just all the data points, forget about it. We are interested in p value, which says 0.485. You remember p low, null go. Now, is this p value lower than 0.05? Yes, no. Is this lower than 0.05? 0.05, not 0.5. Remember this. A lot of people make mistake on this. 0.05, correct? Absolutely not. This is not less than 0.05. So we cannot reject null. Null go meaning reject null. So we have to accept null. What is null hypothesis here? Null hypothesis, standard process is equal to pilot process. The average of standard process is equal to pilot process. Now you can see here, observe here. The mean is 14.65 of standard and mean of pilot is 14.34. There is very minute difference. There is a difference, but that is very minute. Now let me draw something here. If you can understand, that will be great. Okay, understand this. If I draw these 22 data points of standard process where, or let's say this is sample process or pilot process, जिसका average है 13.3, sorry, 14.3, okay. And there is another process called standard process, okay. So this is pilot and this is standard. इसका average है 14.6. If I draw this like this, now can you see the overlapping area? This is very important. Just observe here. This is just a pictorial representation of p-value I'm sharing with you. Okay. Now this overlapping area, this is actually p-value. When I say 0.485, actually it is 48.5% overlap. If this two, let's say bell-shaped curve area is considered as 100%, now understand this. If I consider this complete area 100%, overlapping is 48.5%. Are you understanding this? That means they are very close to each other. Look at my palms here. This is distribution 1 and this is distribution 2. If they are very close, and let's say this, the middle finger is our mean, okay, the average. They are very close and they are overlapping very much. Almost close to 50% overlapping. 48.5 is very close to 50%. Are you understanding? That means there is not much difference between these two values. Means. Are you understanding this? Just give me yes in the chat box. यहाँ तक समझा ये? How many of you understood this? They're very close. That's why overlapping area is very high. यहाँ तक समझा? Everybody? Now, let me give you another scenario. Okay, let's say pilot process is the same, let's say 14.3, but let's say standard process is 15.6. Instead of 14, it is 15.6. Now it will come somewhere here. So this is pilot and this is standard. Now it is, instead of 14.6, it is 15.6. I'm just giving you a, example. Now the overlapping area is this much. If this overlapping area is 3%, let's say, that means 0.03 or 3%, that means they are farther away from each other. Very small amount of overlap is there. That means there is a statistical significant difference between these two means. How many of you got it? So this difference, what they are saying is it's statistically significant from each other. This difference is not statistically significant from each other. How many of you got a bulb-on moment with this? Just type yes in the chat box. Have you got a bulb-on moment with this? Just type yes. Just type BO. Clear? See, these are the averages. Okay. Correct. So these are the averages I'm talking about. If, okay. Now here we are not considering stability right now. Okay. Let's not mix the two things together. Okay. What we are saying, the first case which we tested, overlapping area was 48.5%. That's what p value is, the overlapping area, which is 0.485. Now, if imagine the second scenario, the averages would have been a little farther from each other. See, 14.3 and 14.6, very close to each other. Let's say 14.3 and 15.6, they are a little farther. Now, in that case, the distance between the mean can be statistically significant. The moment it crosses 5%, the statistics says it is significant different. The moment it is more than 5% overlap, that is not statistically significant difference. If it is going away, the moment it crosses 5%, which is 0.05, that is p value. Clear? Just type yes. If it's going, 5, if it's crossed the line of 5%, it has become significant difference now. Clear? Very good, very good. And this is called hypothesis testing. Okay. Now, where you can do that, if you want to check two vendors with each other. Okay, two cricketers with each other. Two shift operations with each other. Two departments with each other. Then you can go for two sample t-test. Whether any statistically significant difference between two shifts, two operations, two products. Okay, so you collect the data, put it in the software, and software will give us whether the difference is statistically significant or not. This is called hypothesis testing. I just covered very briefly. Okay, when we go in the advanced level in the black belt, there are almost 10 to 12 different types of hypothesis testing we are going to cover. Clear, everybody? Just give me yes in the chat box. Super, super, amazing. Okay, now let me share a file with you. Okay, now we are talking about correlation and regression. Okay, before we close the session today, we'll cover correlation and regression today, which is very, very important topic in our studies. Okay. Yes. So let me open the file. I've given you a file. Can you just open that quickly? And let me know the file is opened. Okay. Now, meanwhile, let me give you a quick analogy about it. In some cases, there is, for example, let's take test of T example, okay? Test of T. Now tell me, if test of T is my Y, okay, and one of the X is sugar. Sugar is one of the X. X1 is sugar. Okay. Now, if there is zero sugar, the test will be pathetic. So test will be like this. Zero, let's say if this is zero, or let's say this is 0 point. So test will be very low. Okay, like this. Then if I keep on adding some, let's say half a tablespoon, 1 tablespoon, 1.5, 2 tablespoon, my taste can go a little better till the time I, let's say I complete 2 tablespoon at least. Okay. So the moment I add the sugar, my taste is increasing. This is called as a positive relationship or positive correlation. Okay. Second example I'll give. Again, the test is on the y-axis, and let's say water. Okay. Now imagine instead of a specified amount of water, if I keep more water in the kettle. Okay, right? Understand this. If I keep on adding water, let's say test is, let's say at 5. Earlier, I have added only what is required amount of water. And I keep on adding water. What will happen? The test will deteriorate and it will show a downwards pattern. And that downward pattern is, that means my x is increasing and my y is decreasing, and that is called negative correlation. Okay. And another example is environmental temperature, surrounding temperature and my taste of tea. There may not be any relationship. So my pattern will be like this. That is called no relationship. Are you clear with all the 3 examples? Just give me yes in the chat box. All the 3 examples are clear. So this is called establishing relationship between X and Y. It is called correlation. Establishing relationship is called correlation. Okay. Now here in this file, okay. Yes, exactly. Total quality management is X and your quality is your Y. So that the more TQM, etc. you are following, then better will be your quality. It's a positive correlation, right? Very good. Now coming back to your file. Now in this file, there are 2 columns given. Okay. In the first column, you have profit of a company, and the second column, you have expenses in learning and development, L&D. Now, profit is in crores of rupees and expenses is in lakhs of rupees. Okay. Now, they want to see, is there any pattern, positive, negative pattern in this? So they want to check that. So we will also find out that. Let's find out how we can find out that. Go to graph. And the first option here is scatter plot. Just check that out. Go to graph and the first option is scatter plot. Once you click on scatter plot, this window will appear. Just select simple. Graph mein first option is scatter plot. Okay. Select simple. Now tell me profit and expenses of learning and development. What is output and what is input? What is output? First, let's answer this. What is output here? P for profit and E for expenses. What is output? Just type P or E in the chat box. Here, what is output? Everybody. Very good. Profit is the output and expenses is the input. Clear hai? So in the Y, just select the profit, and in X, select the expenses. Okay. And say okay. Now just observe this graph, just dots very closely. Are you observing any pattern, positive, negative, or no correlation? P for positive, N for negative, and NO for no correlation. Type in the chat box. P for positive, N for negative, NO for no correlation. Everybody's observing positive? Yes. So you can see here, you can see a little, if I have to draw something, it would be like this, right? When my expenses are increasing, my profit is also increasing. It is showing a positive relationship. Yes, very good, very good. Now, this is called correlation. Okay. Now, let's do something called regression. What is regression? Okay, let's go to stat. regression fitted line plot. Just follow this path. Stat regression fitted line plot. Stat regression fitted line plot. Okay, just click on fitted line plot. In Y, select annual profit. In X, select expenses and say okay. Now on the same graph, there are three additional informations we have got. What are the three additional information? Yes, first is called, this is called line of best fit. Okay. So you get a line which passes through these dots. Along with that, you get R square value, 76.58. What is R square value? R square value is nothing but if it is between 0 to 33%, it is very low relationship, low strength of the relationship. Okay. If it is between 33 to 66%, you have moderate or medium, you can say moderate relationship. And 66% above, you have strong correlation. Now, see, in our life also, we have very close, tightly bound friends, right? Where we can share everything with them. बीवी के साथ झगड़ा हुआ, we can share with them. बॉस ने डांट दिया, we can share with them. Are you understanding this? Yes. Business में loss हुआ, we can share with them. And they also share their private parts, private things with us without any hesitation. This is called very strong bonding. There is a trust in the relationship. There is something moderate as well, where we know each other, but that not very close with each other. And low meaning we are either don't know each other or kind of hi hello. That's it. Okay, similarly, these three levels you can remember. Okay, now when it comes to strong correlationship, 76 means there's a very strong relationship between expenses and your profits. Okay, yes. And then the third part is called as regression equation. The equation is y is equal to a plus bx. Now understand this. This is very interesting. Where y is output and x is input, we all know. Correct? What is A? A is nothing but intercept. Write this down, I'll explain you. And what is B? B is equal to slope. Just make a note of this. Once you have made the note of this, please let me know. Clear? Y is equal to A plus BX. In that, Y is the output, X is the input, A is intercept, B is slope. Now, what is intercept? Understand this. If I extend this line of best fit, this is line of best fit, red colored. If I extend this, it will intersect this y-axis at this point, and this point is minus 1.87, 1817. This is called A. And what is B? B is this, plus 0.1883. This is B. What is B? B is slope. What is slope? Try to understand this. Okay. Now, L&D expenses in lakhs of rupees. Okay. And my profit is in crores of rupees. Now try to understand this. L&D expenses is, let's say, one unit is, let's say, 1 lakh rupees. Understand this. Okay. Now we are increasing the L&D expenses from 20 lakhs to, let's say, 45 lakhs. 1 lakh rupees we are increasing. Now, if I put 1 lakh rupees additional, how much positive impact it is giving on my Y? That is what the slope is. So, what is slope? Change in Y with 1 unit change in X. It's called as slope. That means in the tea test example and the sugar example, if I add 1 tablespoon how much taste will increase? If I add another tablespoon, how much taste will increase? That additional deviation which I'm getting, that is called slope. So in this case, the slope is, understand this, slope is 0.1883 crore. That means when I put 1 lakh rupees X in my L&D expenditure, I will get 0.1883 crore rupees of profit as my Y. 0.1883 meaning 18.83 lakh rupees. So if I spend 1 lakh rupees on my training and development, skill building of my people, I'm getting 18.83 lakh rupees profit. This is called a slope. Are you clear with this? Just give me yes in the chat box. समझ में आया ये? And this is called regression or prediction equation. Regression or prediction equation. Okay. Now let's do a simple maths. Okay. एक mathematics करके देखते हैं. I'm just removing this now. With this equation, okay, can we calculate what will happen if we spend, let's say 30 lakh rupees on L&D expenses? So I am giving you X is equal to 30. Okay. So Y is equal to A plus BX, right? So this is the equation you have. X value I have given, X is equal to 30. Can you tell me the value of Y? Calculate this and tell me the value of Y in the chat. So declaration is, when I'm spending 1 lakh rupees in my L&D expenses, I'm getting 18.83 lakh rupees profit. That is called my slope. Okay, now let's calculate. This is the prediction equation. With this equation, let's calculate the profit. If I have 30 lakh rupees to spend, how much profit I can expect? Type in the chat box. Yeah, let other people also calculate it. Sadaranji, very good. You have done it very fast. So I'll disclose it once other people also. I want people also to calculate. Very good. Is it 3.8 or 3.9? Yeah. 3.832. Okay. So see, I also can find out, understand this. If I draw a line vertical to 30, and if I draw a horizontal line exactly like this, now again, I'm just doing it. This will be around this 3.8 mark. How many of you got it? So when I put 30 lakhs in the L&D expenses, I will get 3.8 crore rupees ka profit. Got it? This is called a slope. And this is the power of regression equation. So clear? So we have covered hypothesis testing and regression today in this. And of course, before that, we covered the Minitab, we have covered MSA and a lot of things which we will revise tomorrow. Okay, so today's session was a little heavy because statistics and Minitab was there. So we'll stop here. It is already 9:30. We'll stop here. We'll connect again tomorrow. We'll do the revision of today's session. Tomorrow, I'm going to cover the control charts as well. Tomorrow, I'll cover some improved phase tools and control strategies. And the people who are ready for the examination can take the examination tomorrow for the green belt. Okay, I'll explain each and everything for tomorrow. Okay, any question for today's session? If you have, you can just put it in the chat. I'll answer that. If no, we'll close the session. The recording will be available in Hackathon, Green Belt Hackathon. Okay, not in Masterclass Archive. I told you yesterday as well. Clear? Just give me yes. थोड़ा सा हेवी था बट मजा आया कि नहीं? Give me yes or no in the chat box. Yeah, थोड़ा सा difficult था hypothesis को सीखना वगैरह, but that's the fun, right? That's the fun. That's where the interesting part lies. Superb. Thank you very much for this superb your positive comments and recognitions. Thank you very much. Okay, yes, practice is required. Practice will make you perfect. That's it. Okay. Thank you very much. So we'll connect again tomorrow. Come with the Minitab software and the laptop. Come prepared so that we will do a lot of exercises tomorrow as well. Okay. Thank you very much. Keep learning, keep growing. This is Dinesh Patil signing off. Bye bye. Good night. We'll connect tomorrow at 7.